Two of the types of reactions that you're going to need to be able to identify are combination and decomposition. So in the center here, you will see, this is like just writing it as generic as possible without anything specific, but to give you an overall pattern. So what I use to help me remember what's happening is I look at the word combination and I think of combine. And when you combine things, you bring it together. And so combination reactants are when you have two reactants that go into one product. And so the thing you're going to look that's in common with all combination reactions is that you have just a single or one product. Now, I'm not talking about the coefficients. For example, there's a 2 here in front of the sodium chloride. There's still only one product. There's still only sodium chloride. The 2 there is for balancing to make sure that the equation matches the law of conservation of mass. So to identify these, we look for a single product. And I was going to erase that so we could look a little more clearly. So here I have my reactants are on the left, so I'm reacting sodium and chlorine, and I make sodium chloride. Right here, this is calcium oxide and water. I have 2 reactants, and I make calcium hydroxide. Aluminum and bromine, 2 reactants to make aluminum bromide. So again, all you have to be able to do is identify these types of reactions. So if I gave you one of the equations on this page, you could look at it and say, oh, that represents a combination reaction. You do not need to be able to predict the products for these. Now, the flip of this, like almost a cousin, I don't know how you want to say it, but it's decomposition, and you'll see. Again, in the center here is a generic way without really writing chemicals, but trying to get you to see the pattern. And I think of decomposition, I think of this word here, and I think of decompose. And when things decompose, they break down or fall apart into pieces. And so this is a situation where we only start with one reactant, and then it breaks down into multiple products. Now in this example, the ones I have all have 2 products, but if one of them broke down to 3 products, I would not feel nervous about that. If it starts with one reactant and breaks down into its pieces, so whether it's 2 pieces or 3 pieces or even 4 pieces, if it's breaking down into pieces, it's decomposition. So what we notice here, one reactant breaks into pieces, 2 products. One reactant breaks into pieces. Here we have this and this. And then one reactant breaks into pieces. So this is the reverse of combination. Combination is when you have multiple reactants and you make one product. Decomposition is when you have one reactant and you break down into multiple products. Now, just to test yourself on something that we've done recently, and that was last week's lab, this was what we did. We took magnesium ribbon and we reacted it in oxygen from the air, and we got magnesium oxide. Now, if we balance it, we need 2's here. Okay, so there's our chemical equation. You can pause the video, and then I want you to try to decide, is this combination or decomposition? And then I will give you the answer, but just pause the video and see if you know. Okay, this is combination, right? Because I have two reactants and I made one product. So in combination, we have one product from multiple reactants. Now here's another reaction. And I have balanced it. You know, if you're worried and practicing balancing, you can write these equations on a separate piece of paper without the coefficients and then come back to them later and see if you can balance them. Like maybe on one side you write them without the coefficients and then on the back side write them with the coefficients and just test yourself. That's how you get better at things, is by practicing, testing yourself. Use things you know the answers to, so you know where you're having trouble or where you're doing it right. Okay, so pause again and see what you think about this second one. Okay, hopefully you thought decomposition. So in this one, we have one reactant, and see how it breaks into its pieces. It falls apart. So for these two types of reactions, this is what I'm going to want you to do. I'll give you a reaction, and I want you to classify it either as combination or decomposition. Now in the next two videos, I'm splitting apart single replacement and double replacement, because in those reactions, we're going to predict the products. So those are in two individual videos.